Good day, amazing scientists. It's your favorite sensei here, Sensei Mohao, and we are back again with our lesson on sigma notation. So, in the previous lesson, we were dealing with arithmetic sequences, the sum of arithmetic sequences, the sum of infinite sequences, and also past question papers on that. So, on this lesson today, we are gonna be dealing with sigma notation. So hope you all are ready. If you are new to our family, please press the subscribe button down there below, and also don't forget to click the notification bell so whenever we post a new lesson you will be updated. So if you haven't yet watched the other videos, I will share the link of the playlist in the bio, so hope you check the other videos out. And also we have made different playlists. I just put that on silent, it's disturbing. Have made other playlists where we were dealing, where some of my tutors or my entire team of tutors were dealing with other topics such as history, such as accounting, such as economics. So if you might be having challenges in those subjects, we have made videos especially and exclusively for you, so check the playlist. I also try to put the link of the other playlists in the description of this video. So hope you'll enjoy the video, and let's just get straight into it and do the work. So what is a sigma notation? So a sigma notation is represented by this letter. It's more or less like an E, ne? So it's more or less like E. So basically it just means the sum of a specific term, ne? So let's say for example it means, let's say for example, the sum of, probably let's say for example, the sum of terms in this equation, and in the number below it shows the lower limit, which means the first value of the terms. Let's say for example we have the n1 and we are given tn equals to 2n, ne? So which means the first term, it's n, t of 1 is the first term. So if probably here they changed the number here, let's say for example they gave us 2 or 3, 2, it means the first term will be on t2, ne? It will be the first term in the sequence. So please keep that in mind. But we'll do other tough exercises so that you will understand this part. So this means this is the upper limit, it's the last value of the sequence. So let's say for example we have 10 there at the top. It means that if here it's 10, which means that the last term of the sequence it's t10. Here, let's try finding t10. It will be the last term of the sequence. t10 equals to 20. So which means the last term of this sequence will be 20. And on the side here it's the formula for the terms, for the number of terms, or it's more or less like the equation of how you find the terms, né? So let's get straight into doing the questions, because of here on sigma notation it's basically a sum up of all the previous lessons that we did on finding the sum of the sequences of the arithmetic sequence, geometric sequence, infinite sequence, ne? So this is basically just a sum up of that, so it will be easier for you to understand how we evaluate the sigma notation and how we found the number of terms or the sum of terms in that particular sequence when we do exercises with it, ne? So let's get straight into work and try doing the first example. So the first question here says, place the following. sequences in a sigma notation. Okay? So on number, the first one, we have 1, we have 2, we have 4, 8, 16, 32. So judging by these numbers, this is a geometric sequence. Né? It's a geometric sequence. So let's find the ratio. Let's check by finding the ratio. T2 over T1, it's 4. Okay, sorry, it's 4 over 2 equals to 2 over 1. The answer is 2, the ratio is 2. Yeah? So it's A, R, minus 1. So it's 1 into 2 and minus 1. So let's try to find which, the last number, what term is it? So this is the Tn. So let's say 2048 T n minus 1. Let's put 2048 in the base of 2. It's 2 to the power 11 gives us 2n minus 1. Therefore 11 n minus 1 n will be 12. Né? So this is the 12th term in the sequence. Okay. So since it will be the 12th term in the sequence, let me erase this quick. It will be the 12th term in the sequence, so it's gonna be E equals to n equals to 1 from the first term till that till the 12th term, and here will be just the term, the general formula. So this is how we do it. Let's do number 2. You can try pausing the video, try doing them on their own, then after unpause and check your answers just to practice and see if you get the gist of this thing. So the second term, it's also a geometric sequence. Let's find the ratio. T3 over T2, T2 over T1. It's 13 over 26 equals to 26 over 52. The answer will be 1 over 2. This is the ratio. So let's find the general formula. So it's 52 into half and minus 1. Let's find what term is this thing. So now check here that the last term we are given is 3,25. So this is the last term in the sequence. Right? So the last term in the sequence is 3,25. Let's do this. 3,2. Oh, it's 1, 2, 3, 4, 5. So this one is just easy since they already gave us the last term. So it's the 5th term, n is 1. Then this is the Tn, the general formula, 1 over 2n minus 1. So this is how we do it. Easy one, this one. Let's do the other one. So in the third one, it's 7 minus 2 minus 3. Okay, let's check the ratio. It's 2 over 7 and negative 3 over 2. No, this is the arithmetic sequence. So it's T2 minus T1, T3 minus T2. It's 5 minus 7 equals to minus 3 minus 2. It's negative 5, negative 5, the constant difference. So let's try finding the sequence. Yeah? Oh, sorry, not the sequence, the total number. Sorry, the general formula. Sorry. It's 7 plus n minus 1 into negative 5. We have 7 plus, okay, negative 5. Just negative 5 n plus 5, and our answer will be negative 5n plus 12, ne? Check negative 5n is negative 5 plus 12. Okay, the second one is 10 negative. Okay. So this is it. I was just checking if whether I didn't do any mistake there on factorizing. You need to check always, ne? So let's check the last term of the sequence. It's negative 68. We have n plus 12. Take this 12 to the other side. It's gonna be minus 5. Okay, let me just take this to the other side. And 12 plus 68. Ne? So it's 5n equals to 12 plus 68 is gonna give us 80. Ne? Then divide that by 5. It's 16. Ne? 80, then n is 16. So this is the 16th term in the sequence. So whenever we're doing our sequence notation, is going to be 16, which is the upper limit. The lower limit is 1, and the formula, just do it here, plus 2. That's how we do it. Then move to the last one. So in the last one, we have 4, 12, 36. So here it seems like we multiply by 3. Let's check the ratio. 12 over 4 equals to 3. 36 over 12 equals to 3. So this is the geometric sequence. So okay, it's gonna be ARN minus 1. So it's 4 into 3n minus 1. So we found the general formula. So let's check, since now here it's the last term in the sequence, ne? Because we don't see any ellipses, to check to see that there are other terms missing or left out, ne? So this is the last term in the sequence. So let's try finding what term is it. So divide by 4, 3n minus 1. So let's use a calculator quick. It's 81. This side, 3n minus 1. We need to shift the stick and base it to it, base 3. So 3 to the power 4, 3 to the power n minus 1. We drop down the bases since they are the same. It's 4 n minus 1, and we take negative 1 to the other side, and n is going to give us 4 plus 1, which is 5. So this is the 5th term. Oh, they already, okay, since it's 1, 2, 3, 4, 5, they already did it for us, so we didn't have to do this thing. So yeah, but then you can just learn the step how I found what term is it, just for future purposes, if probably they gave you something similar to this one. So yeah, I didn't notice it up until last minute. So the general sequence is 4, 3 minus 1, and we have upper limit 5, since the sequences we have 5 numbers, and n is 1. Ne? So hope you all get the gist of it. You can take a quick water break, and then after this we try to tackle past paper questions from a past paper on how we are gonna take something like this, ne? A sigma, given a sigma notation, we try to find the sum of these numbers, ne? To find the sum, let's say we're going to list, for example, let's say they give us something like this, we're going to list the first 5 times there in the sequence, something like that, ne? So from here we're gonna go back here, ne? So since here in the first step we took the sequence, we converted them into sigma, so we're gonna do the reciprocal of that. So you can take a water break and then take 5, then we'll come back and resume the video sharp. So let's resume. Welcome back disciples. Let's resume the second segment of the video. So now here we're given a sigma notation. The lower limit is 1, the upper limit is 10, and we are given a general formula on how we're going to find the sequences. So let's tackle that. Ne? So first and foremost, we have to find the first term. Let's say just the first 3 terms. Ne? We're gonna find the first 3 terms. Then here, after finding the first 3 terms, we will find the sum of this sequence. Ne? Since sigma means the sum of a sequence, so we're gonna find the sum of the sequence. So it's essential for us to find the first 3 terms. We will be using this general equation since they already gave us the general equation. Ne? So T1 is T of 1. Note that here the first term it's T1. Ne? The first term is T1, so which means T1 will be T1. In other instances we're not gonna be getting 1 here as the lower limit. So in that instance we will do it later on, and I'll show you how you tackle that one, whereby the lower limit is not 1. Ne? T of 1 plus 3 is 5, and T of 2 plus 3, which is 4, plus 3, which is 7, and I assume it's 11. Ne? I'm just assuming, it's just an assumption. Tn plus 3, no, it's not 11, so it's Tn plus 3, it's 5, Tn2 plus 3, it's 4 plus 3, which is 7, and this is okay. Oh, sorry, it's 5. I was just reading the okay. It's 5 plus 2 plus 2, which is 9. So 6 plus 3, which is 9. Ne? So the first 3 terms we have to write them. Okay, let me just do this. First 3 terms in the sequence. It's 5, it's 7, it's 9. So since now there's an arithmetic sequence, we will find this. How do we know that it is an arithmetic sequence? We can find the general difference here, that T2 minus T1 and T3 minus T2 is 5, 7 minus 5, which is 2. Ne? In other instances, we can check using this formula that we were given. So the first term of the 10 terms, remember the arithmetic, the sum, the general formula to find the arithmetic sequence, it's Sn equals to, and okay, so now here, since we know that the last term of the sequence, so now here we can use this one, or we can use this one, n over 2a plus l. Right? So it's the 10 terms over the first term is 5 plus the last term 23. So we know that 5 multiplied by 28, it is gonna should give us 140. 5 times 28, yes, definitely gives us 140. Ne? So this is how we found the first term of the sequence. Let's try tackling the other ones. Ne? So you all may wonder, why didn't I use this first equation? The reason why I didn't use the first equation is that we are given this equation, and it has, now that we know the last term of the sequence, we can just substitute with the last term of the sequence and the first term of the sequence and the number of terms. Ne? So this made a few changes. So it's E it's 0 and 1. So now here, let's say probably we are looking for the sigma notation, eh? So note that the lower limit is 0, the upper limit is infinite, which means that it's an infinite geometric sequence, eh? So the first term will be t of 0, 1 over 3 0, it's gonna be 2. Second one is gonna be to the power 1, 2 over 3. The third one, it's 1 over 2, so it's 2, it's 1 over 9, so it's 2 over 9, yeah? So remember, because of multiply by 1 over 3, multiply by 1 over 3, it's gonna give us 2 over 9. Okay, sorry about that. So whenever, because of now, remember the r is less than 1 but it's greater than -1, which means it is a conversion. We can try finding the limit, né? So it's 8 minus 1 over r, so it's 2 minus 1 over 1 over 3. It's gonna be 2 over 3, which is gonna give us 2 divided by 2 over 3. It's 2 multiplied by 3 over 2, so it's gonna be 3, né? So 3 will be our limit. Remember, if 3 is our limit, which means for this the terms will keep decreasing, and whenever they won't increase. Note it's 2 over 3, it's 2 over 9, so they keep getting smaller and smaller, and whenever we do the sum of it, they will all limit us to 3. There will be 3, which means the sum of the number of terms will not exceed 3, which is our limiting factor here. I had a very nice time doing this video with you, and I hope you all enjoyed the lesson. So if you have not yet subscribed to our channel, please do the right thing. Tell all your friends, your neighbors, your cousins, your classmates that the sensei is back with a fresh new lesson of sigma notation, dealing with evaluation past papers of sigma notation. And I hope you enjoyed the rest of your day. From me, your favorite sensei, peace and love. We out. See you in the next video.